Example 1.6. A cubic foot of air at atmospheric pressure of 14.7 psi is compressed isentropically until it reaches half a foot cube of volume. This is done by the use of a tire pump. We need to determine the final pressure of the air using these conditions. K for the air is equal to 1.4. From this problem, we know that the volume changes as well as the pressure. However, because it's a closed system, the amount of the mass remains constant. At the first stage, we know that the mass is going to be equal to the density at point 1 times the volume at stage 1. And we know that the mass is going to be equal at stage 2 at density 2, volume 2. Since the mass remains constant, we could say that density 1, volume 1, is going to be equal to density 2, volume 2. We know that the density 1, we know that the volume at the beginning is 1 cubic feet, and we know that the density 2, we know that the end, the volume is equal to half cubic feet. Therefore, we see that density 1 is going to be equal to half of density 2. And we're going to be able to use these quantities later on. We already know, using an isentropic process, that the pressure 1 divided by pressure 2 is going to be equal to density 1 to the value of K divided by density 2 and the value of K. We know from here that pressure 1 divided by pressure 2, we know density 1 is going to be half of density 2, and this is equal to density 2 cancels, and this is to the K power. So we know that P1 divided by P2 is going to be 1/2 to the K value. Using this, we could say that the pressure at point 2 is going to be equal to the pressure 1 times 2 to the K value. And if we substitute the value, the pressure 2 is going to be equal, pressure 1 is equal to 14.7 psi, and then we have 2 to the value of K, which is equal to 1.4, and at the end this gives us the value of 38.8 psi. Please go back and double check the calculations and be able to derive this equation and get the solution.